Aloha and welcome back to Maui Huliau Foundation's virtual classroom. In this part, you will be learning about the terms climate and climate change and what they mean. Although climate and weather may sound like the same thing, they are actually not the same, but they are related. Let's start with weather. Weather is the current atmospheric condition or what it's doing outside right now, and it includes a number of conditions. It includes things like temperature, or how cold or hot it is, humidity or moisture in the air, wind speed and direction, and precipitation like rainfall and snow. So then what is climate? You can think of climate as the average weather over time, or what the weather patterns are at a certain location or time of the year. Let's look at some examples of weather versus climate. During the winter, we know that Maui is rainier and colder, but sometimes in the winter you have hot sunny days. That hot sunny day is an example of weather. The climate, or the average weather over time, is still much cooler and rainier during that season. That's the difference between weather and climate. If we look at a different part of the world, you will see different examples of climate. A desert in Arizona experiences a very different climate compared to Maui's climate. We will get into why later, but even during the same season, these two places have a very different climate. If you want to learn more about weather versus climate, check out the videos in the additional resource folder. So what exactly influences Earth's climate? The energy needed for life on Earth comes from the sun. A lot of different factors that influence climate come from how the Earth moves in relation to the sun throughout the year. Revolution, or the orbit of Earth around the sun, is one factor. Do you know how long this takes? If you guessed 365 days or 1 year, you're correct. At the same time that the Earth is revolving around the sun, Earth itself is rotating. Earth's rotation is on a fixed axis. Imagine a line passing through the center of the Earth from the North Pole to the South Pole. Earth rotates and completes one full rotation in 24 hours, which is what gives us day and night. And lastly, the axis, or that imaginary line, is slightly tilted. So different areas around the world lean closer to the sun during different times, resulting in different amounts of sunlight and heat. And that is how we get seasons. During the northern hemisphere summer, north of the equator gets more sunlight and heat, and the southern hemisphere gets less, making it winter. This is reversed 6 months later. During spring and fall, both sides of the equator get more equal amounts of sunlight. Don't worry, I know it's a lot to take in. After this presentation, watch the video Earth's Rotation and Revolution in the introduction folder for a visual of how Earth moves in relation to the sun. Now that we know how Earth's movement around the sun impacts climate, let's look at how wind and ocean currents move the sun's heat around the planet. Surface ocean currents are driven by wind. These currents transport heat from the tropics to the polar regions and influence climate. Then there's the conveyor belt, or deep ocean currents, which are driven by differences in heat and salinity. As warm currents arrive at the poles, they become colder and saltier, and therefore sink and are replaced by warmer water from the equator. Global wind patterns are also caused by differences in temperature. Notice how the trade winds flow from either the north or south towards the equator. The spinning of the Earth then causes these air currents to curve towards the east or west, as you can see with the westerlies and trade winds in this diagram. This is known as the Coriolis effect, which causes wind and ocean currents to spiral in opposite directions in each hemisphere. If you haven't learned yet about the Coriolis effect, please see the video in the additional resource folder. Warm, moist air from the equator rises, and then drier, cooler air falls as it moves away from the equator. This pattern of rising and falling air creates souths, which create different climates at different latitudes or distance from the equator. For example, warm and moist tropical conditions occur along the equator where warm air rises, while many deserts on Earth are located between 15 degrees and 30 degrees latitude north and south of the equator, where cool, dry air descends. Different regions of Earth therefore have different local climates. or biomes, from tropical forests to deserts to polar tundra, which have different temperatures and levels of precipitation. Within these Earth biomes, other local factors create microclimates. Take, for example, Maui. Maui experiences microclimates, which are largely caused by trade winds blowing across our islands from the northeast. You might have heard of the term windward and leeward. The windward side of each island faces the incoming trade winds and therefore gets more of the rain that is brought in by the trade winds. The leeward side is more sheltered from the wind by mountains and therefore gets less wind and rain. However, sometimes the wind and weather comes from the opposite direction, from the southwest part of the islands, where Kona is located. In Hawaii, we call these less common southwest winds Kona winds. Taking a closer look at windward and leeward, as the trade winds move up the windward side of Haleakala, or the West Maui Mountains, for example, the air cools and condenses, causing more clouds and rainfall. As it moves down the leeward side, the air becomes warmer and drier. For this reason, windward areas like Hana and Waihe'e are wetter, and leeward areas like Kihei and Lahaina are warmer and drier. Remember that elevation also affects microclimates, which is why Kula is colder than Kihei. For these reasons, Maui has different microclimates with different levels of temperature and precipitation. So what is climate change? Climate change is all the changes that take place in Earth's climate as the Earth gets warmer. We will go into detail on these impacts in Unit 2. First, let's talk about global warming. The term global warming, which refers to the Earth's average temperature as getting warmer. The red areas on this map represent areas that have gotten warmer since 1980, while the blue areas have gotten colder. As you can see, not everywhere on Earth is warming at the same rate, but overall, there is more red than blue. A 1 degree Celsius increase in temperature has been recorded since 1800, and since 1980, warming has occurred twice as fast. As we learned in Part 1, global warming is caused by greenhouse gases and the enhanced greenhouse effect, which is caused by too much CO2 being added to the atmosphere. As we learned, CO2 is being added to the atmosphere mostly by human impacts, such as deforestation and the burning of fossil fuels. This average global warming is causing changes in Earth's climate. Climate change refers to the different impacts of global warming, such as warming sea surface temperature and sea level rise. And impacts like severe storms, increase in wildfires, and droughts are occurring more frequently due to global warming. We will explore impacts further in Unit 2. Let's go over the activities that you will be completing in Part 3. In this first activity, Anila Kilo, or weather observation, you will study the weather in your local town and document what you observe, or kilo. You will start by making your own rain gauge to measure the amount of rainfall each day. Note that you need to make your rain gauge and set it out around 24 hours before you begin your first kilo activity in order to record the rainfall that happened in the past 24 hours. You will do this for 4 consecutive days and complete the weather data sheet daily. In the Maui Microclimates assignment, you will compare your averages from your kilo activity to the monthly average in your town. In addition, you will further explore Maui's microclimates by comparing your hometown's climate with another location on Maui. For the Climate Around the World activity, you'll explore the climate in other regions of the world and compare it to Maui's climate. For both of these activities, you will be using the site weatherbase.com. You can find the link in the Google Classroom. In the last activity, you'll study different examples of weather versus climate in the flashcard program Quizlet. After studying these examples, play the match game and test your knowledge. You'll complete this assignment by answering the student question in the Google Classroom. There are additional video resources in the Google Classroom folder. Once you complete all of the activities, you'll take Part 3 quiz. This will complete Unit 1. So once you complete Part 3 quiz and feel prepared with the Unit 1 material on climate change causes, take the Unit 1 test.